All right, finishing up the notes here for 2.3. We got example 7. Y'all's favorite, piecewise functions. Piecewise functions. Piecewise functions. All right, so for a piecewise function, it's probably easier just to sketch the graph and then look at it and answer all the questions related to it. So this one is kind of funky. To the left of -1, it's our parabola. At 0, it's 2. And to the right of 1, it's our line, -3x minus 3. So let's go ahead and give ourselves a y-axis and an x-axis. And then we'll come over here and put the important values of x. Here's -1. There's 0. Here's 1. All right. The top piece is the left piece, right? It says less than, less than. I want to know what the limit is as x goes to -1 from the left. Let me go ahead and write that out. I want the limit as x goes to -1 from the left of p of x. Well, by direct substitution, what is that? What's -1 squared? I can use direct substitution and I get 0, don't I? I get 0. So at -1, do I put a solid dot or an open circle? Open circle because it's strictly less than. Okay. Now I know what x squared minus 1 would normally look like. It would come in like this, carving, and then it would come in through here, and it would cross at -1, and then it would go back out like this. That's what x squared minus 1 would look like. Yes, yes? But I'm not doing all that, so I'm going to get rid of all these dots. I'm only graphing it up to -1, and then we're stopping. So that's that piece right there, and that's curved enough. And then at 0, what is the function value at 0? It says it's 2. That's just a solid dot right there. Okay. And then to the right of 1, it's the line 3x minus 3. I want to know this. What's the limit as x goes to 1 from the right-hand side of p of x? Well, that's the same as the limit as x goes to 1 from the right of -3x minus 3. What do I get when I plug a -1 in? Sorry? -6. Yeah, -6. So I'm going to need that space. I'm going to move this over here, or I'll move it right here. Okay, so I need -6. I'm just going to call this -6. And do I put a solid dot or an open circle? Open circle. And now the slope is what? Positive or negative? It's -3, so I leave here with the negative slope. That's all you have to show. There we go. And there's your graph. That's p of x. Isn't it pretty? P for pretty. Pretty graph. Man, it's broken up big time, right? Big time broken up. Like the 2-point conversion Friday night. Yeah. Anyway, no, we don't have to bring that up. All right, let's talk about the domain. What's the domain of P? Well, this one's kind of funky, right? It's going to be, if we do interval notation, it's going to be x epsilon. Well, let's not do interval notation. Let's do a set notation. It's going to be the set of all x such that x is less than -1, comma, x is equal to 0, comma, and x is greater than 1. That's the domain. It's kind of funky, right? The graph is not defined anywhere between -1 and 1 except at 0. What's the range of this function? What y values does it take on? Let's do interval notation just to get it in. -infinity up to what y value? -6 with a parenthesis or a bracket? Parenthesis. And then union, what's the next y value you start at? 0, good, the x-axis with a parenthesis. And then from there, that left branch cruises up to infinity. We don't get any y values between -6 and 0. Okay, does it have any symmetry? No symmetry. No symmetry. Okay, how about intervals of increasing or decreasing? P is decreasing on the open interval from x equals -infinity up to -1, union 1 to infinity. Would you agree? It's not really increasing or decreasing at 0, is it? It's just existing. Yeah, let's go ahead and say monotonic. It's doing one thing and one thing only over its entire domain, and it's going downhill. What else are we talking about here? Do we have any local extrema? The local max or min? Is 2 a local max or min? Remember, local max or mins can occur at discontinuities. Remember, the ultimate litmus test I said is this. If you can go immediately to the left and find values lower, and immediately to the right and find values that are lower, it's going to be a local max. If I go immediately to the left, are there any values to get on? No. So he's on an island out there. So there's actually no local extrema. Which remember, extrema is plural for max and mins.
But if that, let's say the parabola was a negative 2x or negative x squared and it opened downwards instead of up, would that be considered a local max?
No, because there's nothing immediate. There's no graph to the left or right. Now if it looked like let's say it looked like this, and then there was another value that came out like that. If that's what the graph looked like, would that be a local maximum now? That would be, right? Because now if I look to the left, I see values that are lower, and I look to the right, I see values that are lower. So that would be a local max. That would be a local max. But we don't have that, do we? What if it looked like this? It came like that, and then it looked like this. Would that be a local max or a local min? That would be a local what? That would be a local min, because immediately to the left and right, we see values that are higher. That would be a local min. What if we had that? It's just that means that you say x is greater than 2 or x is less than negative 2. That's what that means. So I'm going to come over here, this is negative 2. Come over here, this is positive 2. I know what the graph looks like in between there, right? one. Very good. Just a random question. Right. That's so fun. Okay, 5 squared. Is